Fraction!
Yay!
Factoring by grouping and factoring out a blob. So we're going to start with factoring out a blob because factoring by grouping relies on factoring out a blob. And then, like we talked about, the trick we're going to learn, Gary's terrific trick, relies on both of these. So what we're kind of doing right now is going backwards. When you get to the end of Gary's terrific trick, you're going to have to factor out a blob. In order to get there, you're going to have to factor by grouping. And then there's another step that you do before that as part of Gary's terrific trick. But we've got to know how to do these things before we can do the whole thing. So factoring out a blob just refers to a problem like this, but instead of x, I could have anything. And so the reason we call it a blob is you'll often see a problem where there's something like this. You guys see how these are really the same thing? X can be anything. So x could be x plus 1. But what I have to remember is I can factor it out as long as I have the same thing in both terms. So in the top one, I have an x in both terms. So this would be equal to x times 2 plus 3. Because x times 2 is 2x, and x times 3 is 3x. So this is really the exact same thing, except instead of x, I've got x plus 1. I've got a blob. So we call this a blob. But I have the same blob in both terms. Right? And so I can factor out that entire blob. I can take out x plus 1. And what I have left is 2 plus 3. So the 2 and the 3 are left because I factored out that blob. Right, I took out the blob, and I just have whatever's in front of it left.
Why can you take out the blob?
Same reason I could take out the x here, because it's the same thing. It's reverse distributive property. If I took this x plus 1 and multiplied it times the 2, I would have 2 times x plus 1. Plus, the entire x plus 1 times 3 would give me 3 times x plus 1. So what these problems usually look like is more like this. I have something like 4x times 3x minus 5 plus 7 times 3x minus 5.
Wait, do you mean to put the x after the 4?
Yep.
Oh.
So what is my blob here?
The 3x minus 5.
Yeah, my blob is the 3x minus 5. It's the same in both cases. So I can factor that out. If I take out the 3x minus 5, right, this factors. And what is my other factor? What's left after I take that out? 4x, not and 7.
Times 7?
Plus 7.
Plus 7. Yeah. So that plus is really important. The fact that there's a plus here, right? 4x plus 7. So I took out the blob, and now I end up having 2 factors.
Wait, Nate, could you FOIL the last thing?
You could FOIL that out, yeah.
Okay.
Well, is the 3x minus 5 and the other 3x minus 5 like terms, so can you add them?
Yeah, I'm gonna.
Well, we factored it out, so there's not 2 of them anymore.
Oh, yeah.
There's not really any like terms here. In the first example I gave, there were like terms. But I was just trying to give a simpler example. So we could have actually simplified that one more. But here, there's really not.
But the 3x.
The 3x minus 5, those are not like terms, right?
Oh, yeah, yeah.
Because this one has an x and this one doesn't. And 4x and 3x aren't like terms because they're not being added, they're being multiplied.
Oh,
Right?
yeah.
If it were like 3x minus 5 plus 4x plus 7, then we could combine like terms. But because it's times,
Then you can't.
there's no way to combine something in here with something in here. Other than to multiply, right? Alright, which is fun. Alright, so let's say we've got something like this. 5x times 2x plus 1 minus 3 times 2x plus 1. What's my blob? The 2x plus 1. So if I factor out the 2x plus 1, do it below this time, what do I have left as my other factor?
5x minus 3.
5x minus 3.
Wait, would you just leave it like that?
This is going to be like your final step, because look, we end up with 2 factors, right?
Oh.
This has kind of always been our goal, is to get these 2 different factors. So this is going to be like the final step of a longer problem. Okay. Factoring out a blob.
Well, you can only do that if they're the same, right?
Right, you can only do that if they're the same. So if I had something like this, I'm going to do it in a different color. If I had something like this, 6x times 2x minus 1 plus 4 times x minus 2.
You can do it.
Yeah, there's not really anything I can do with that. Because these are different. Right? They don't match. So this is not going to be.
If you get that kind of problem, you get like not factorable or something.
Yeah, you never will though.
Oh.
The way this trick works, you know right away from the very beginning if it's factorable. And you only do the steps if it's factorable. Now, you could make a mistake, and if you made a mistake and got something like this, you'd be like, oh, where's my mistake? And you look back and see, oh, right, there was actually a 2x there, not a 2x. So if you ever see something where the blobs don't match, stop and go back and check your work. So that's factoring out the blob. Now let's see what we mean by factoring by grouping. And like I said at the beginning, in order to factor by grouping, we're going to have to factor out a blob. But we're just adding one more step. So it's going to look something like this. And the weird part here is we're used to having 3 terms, right? We're used to something like x squared plus 10x plus 24. So we have 1, 2, 3 terms. With factoring by grouping, the way that you know you need to do this, and this will sometimes come up just on its own, like on a placement test, is because you typically have 4 terms, right? So it might be something like this. 2x squared plus 5x plus 10x plus 25.
Can't you combine the 5x and the 10x?
Okay, so I could combine the 5x and the 10x. But often if someone gives you a problem like this, the easiest way to factor it is going to be this trick that I'm going to show you called factoring by grouping. So factoring by grouping is just what it sounds like. I'm going to group these things by grouping these 2 together and these 2 together. Within the first group, I'm going to pull out anything that I can pull out. So between 2x squared and 5x, what do those have in common?
Nothing.
They do have something in common.
1.
More than just 1. 2 and 5 don't have anything in common, but that's not all there is. Yeah, they both have an x. So we could actually pull out an x. And that would leave x times 2x plus 5. Don't forget that in between these 2 groups is a plus symbol. I've got a plus symbol here. And then I'm going to look at these 2.
2 and 5.
Yeah.
What can I pull out of those?
5.
I can pull out a 5, leaving
2x plus
2x plus 5. So I grouped the first two and pulled out what I could. I grouped the second two and pulled out what I could.
Oh.
Now what do I do?
Then you get the blob. So
Then I get the blob.
X plus 5 is 2x.
And it does not matter which way you write it. So I'm grouping the first two terms together, pulling out whatever I can pull out, grouping the second set of two terms together, right? Pulling out whatever I could pull out, and it just happens that now I've got the same blob. So then I pull that out. Let's do another example of that. What if I've got something like this? 3x squared plus 9x plus 4x squared. Oops. Not x squared. 4x plus 1. So what do we immediately notice?
There are 4 terms.
4 terms.
You
So
group it?
because we've got 4 terms, we're probably going to want to group it.
Those have 2. The first one has 2 things.
You can pull
Yeah.
out 3x.
And this is really important. I'm always, pretty much with this trick, I'm always going to pull out an x from the first 2 terms. But here I can actually pull out a 3 and an x. If I pull a 3x out of these 2 terms, what's left?
X squared. Right? No,
Not
no,
x
no,
squared,
not
because
x
x
squared,
times x will give me this
Yeah,
squared.
just
So
x.
just x plus 3. Remember, there's that plus in between, and then what can I pull out of the second 2 terms?
4.
Pull out a 4, and what do I have left?
X plus 3.
X plus 3. Okay.
So
Now I
you-
immediately see, oh, I've got that blob. So if we pull out the blob, what's left?
3x plus 4. And
3x plus 4. Right? So group, factor out the blob. Okay, I'm going to leave that one up. Let's look at something like this. What if I had 4x squared minus 10x? And then I had minus 2x plus 5.
They all have in common the x and 2.
And there's a minus.
So I want to group these. What do these have in common?
X and 2.
Okay, so pull out a 2x. And what's left?
2x
2x
minus
minus
5x.
just 5.
Yeah, just
Just
5.
5 times 2x. Okay, now here's the trick.
You have minus.
When I see a negative here, I've got to remember what negatives do with the distributive property.
So you can make everything in the.
Yeah, so if I, for example, in this one, there's nothing really in common between these, but I don't want it to say negative 2x plus 5. I want it to say 2x minus 5.
So you distribute the.
So I could actually pull out a negative 1. And then do you see how what's left is a positive 2x and a negative 5? Because the negative 1, the minus, distributes to both things in that second set of parentheses.
Oh, I get it.
So when I pull out a negative, I have to remember to switch that second sign. No matter what the negative is, this could be negative 5. It's still the negative is going to switch that second sign as well as that first sign. Okay. So now I've got 2x minus 5. I can pull that out because that's my blob. And then I've got 2x minus 1. we're done. Let's try to do one more example because I want to do one that has a negative, but it also has something else. So let's look at this one. What if I had 10x squared minus 15x minus 12x plus. Okay, so what do I see in the first two?
5x.
Pull out a 5x. And that leaves me with 5 times what will be
2x.
2x minus 3. Now here I'm going to pull out a negative because I want the x to be positive. So what could I pull out? A negative 6. And that's going to leave me with negative 6 times what is negative 12x? 2x. Negative 6 times a negative 3. Negative times a negative gives me the positive 18. Okay, now I pull out my blob. And what do I have left?
5x minus 6.
5x minus 6. Beautiful. Okay, that was a lot of examples. Right? But that's kind of the way this works. All we're really using is the distributive property. We're just using it in kind of weird ways. Alright, that's good for today.
Subscribe.